Hi everybody. This is the homework review for the section 6.6, Graphing Systems of Linear Inequalities. Your first problem was problem number 8, and it asked you if a given ordered pair was a solution to a given system of linear inequalities. We know that something is a solution if we plug it in and we get a true statement for both inequalities. And when I plugged in 8, 2 to the first inequality, I got a false statement because 20 is not less than or equal to 17. So I didn't even have to check the other inequality. I knew right away that this was not a solution to this system. Okay. Number 10 was next, and this we had to graph on here. We had to graph these two given inequalities. The first one was already written in a way that we could graph. We've got y is less than 2x plus 2. So that's line number 1 right here. I went to my, 2x plus 4. Don't know where I got that. Went up to my intercept of 0, 4. Applied my slope up to right 1 or down to left 1, down to left 1. It's a dashed line because this is not or equal to. And I shaded below because it wants y is less than that. So that's the shade down here. Right? Now the second inequality it gave us had to be manipulated in order to put it in y inequality mx plus b so I could graph it. So I added 3x to both sides, divided every term by -2, which meant I had to flip my inequality sign. So you should have ended up with y is less than or equal to -3/2 x plus -3. So I graphed my intercept at -3, applied my slope, up 3, left 2, or I could have gone down 3, right 2. It's a solid line because of this or equal to right here. And then I applied my slope. Then I shaded below because its y is less than. So it's these lines here. Then you can see where the two shadings overlapped is my solution, which is this section right here. Okay, that's number 10. I've marked line 1 and line 2 on all these so that you can see which line was which. Okay, let's go to 14. So here we have y is less than 2x minus 3. So graph 0, -3. Apply your slope up to right 1, up to right 1. It's a dashed line because it's not or equal to. And then I shaded below it because its y is less than that value. Okay. Then the second one is y is greater than 5. So we go to where y is 5. 1, 2, 3, 4, 5. And we shade above. It also is dashed because it's not or equal to. And then where these two shade areas overlap, right here, that's my solution. Okay. All right, let's look at 20. Again, we had to manipulate these equations a little bit, or these inequalities a little bit, so that we could graph them. So the first one, you can see how I solved for y, and I got y is greater than 8x minus 4. So I went to -4. You can see I went by 2's here on my graph. And then I graphed up 8, up 2, 4, 6, 8, right 1, up 2, 4, 6, 8, right 1. It's dashed because it's not or equal to, and I shade above it because y is greater than that line. Then my second one, 4x plus 8y is greater than 4. I'm going to subtract 4x from both sides, divide everything by 8. I get y is greater than -1/2 x plus 1/2. And I'm going to graph my 1/2. Then I'm going to apply my slope, down 1, right 2, or up 1, left 2. Again, it's dashed, and it's greater than, so it goes up this way from that line. And my solution is where they overlap, which is this area over in here. Okay? All right. Then we went to our next problem. We'll pull that up here. Where's my other guy? All right. He's hiding, guys. There he is. All right. Number 22 asked us to write the system of linear inequalities when we were given a graph. So there were two lines on there. The blue line was a solid line, so I know that it's or equal to. It also was shaded above, so I know it's greater than. And then I just found the intercept of 0, 2, and I found the slope was down 2, right 1, or up 2, left 1. So there it is. Y is greater than or equal to negative 2x plus 2. Then if you look at the orange line, it was dashed and it was shaded below, so that would be y is less than. Again, I found the intercept at 0, negative 2, and then I found the slope, up 3, right 1. Okay? Now the most important ones here are our story problems, so let's get to those. 26. We tell ourselves that C is the hours at the clothing store and M is the hours mowing. We were told our first relationship here, line 1, was that I made $10 at the clothing store, $12 at the mowing job, and I wanted to make at least $350. So what I made, $10 for every hour at the clothing store, $12 for every hour mowing, had to be greater than or equal to $350. I told you to graph these using intercepts, right? Standard form. So you'd go over here and you say if C was 0, right? M would be 9 something. Excuse me. If C was 0, M would be about 29 something. So I graphed that right here. Okay, see my little arrow here? Okay. Then I made a 0 for M, and I said if mowing was 0, I could do 35 or more at clothing. So here's 35 on C. And then I joined those 2 points and I shaded above it because it was greater than. So that's line 1. Line 2, C had to be greater than or equal to 10 hours. So I had to work 10 or more at the clothing store. So I go to where C is 10, there's line 2. And I shade to the right because that's where C is greater than 10. Then the last one, I had to work no more than 35 hours. So hours mowing plus hours at clothing had to be less than or equal to 35. So that's 35 intercept and 35 intercept, solid line between those, and shade down because I needed less than that. So here's my solution, this section right here, where I'm greater than 10 on the clothing, but less than this top line and greater than this. This is where the shading overlaps. So that's my solution, where all 3 are true. Okay? Now if you put a C over here and an M over here, your graph's going to look a teeny bit different. Your solution's going to be up here somewhere, and that's okay. It doesn't matter whether you put M here or C here. Remember, they're codependent, so it doesn't matter which one goes where. Okay? Remember that if you put your C over here, this L2 is going to be a line going this way, right, on the 10. Instead of vertical, it's going to be horizontal if you put your C over here. Okay? 27, we have our driver A goes 60 miles an hour and driver B goes 55, and they want to drive at least 500. So again, find your intercepts. I'm at about 8 something for 8 and about 9 something for B. So that's my first line, and I shade above it. Then we want to drive at most 10 hours a day. So the sum of their driving hours is less than or equal to 10. So here's 10 for A and less. Here's, 10 for B and less. Okay. Then the last one said that A wanted to drive more than B, or B wanted to drive less than A. So that's this little dashed line here, guys, where we want to make sure that whatever value we pick, A is greater than B. That's just like if it was Y is greater than X. It would just be through the origin, a slope of 1 over 1, it's dashed, and we would just go above it. So our solution is where all 3 of those fall together, which is right there. Okay? All right. Next, we have our garden. So we have length and width of our garden are our unknowns. 2 times the length plus 2 times the width has to be less than or equal to 150 because that's the total amount of fence I have, and that's the perimeter. The length has to be greater than or equal to 40, and the width has to be greater than or equal to 5. So I put L over here, W over here. Again, you could put them in either place. It's okay, but your solution will look a little different. And I should have a line at 5 for W, shade that way. A line at 40 for L, shade above. And this is my little solution where all three meet. How I got 75 for length and width is I did the intercept. So if L was 0 and I solved for W, I would get 75. And if W was 0 and I solved for L, I would get 75. Okay? Keep plugging away at these guys.